Hello viewers, in today's lecture we are going to take up the concept of variance of a discrete random variable. Now in our earlier videos we have discussed the concept of probability distribution, the concept of random variable, and then we have discussed the mean of a discrete random variable, right? So in today's lecture we are going to take up the concept of variance of a discrete random variable. Now let x be a discrete random variable, and suppose x takes the values x1, x2, x3 and up to xn, right? And let the corresponding probabilities are p1, p2, p3 up to pn, right? So here we have x be a discrete random variable, and x takes the values x1, x2, x3 up to xn, and let the corresponding probabilities be p1, p2, p3 up to pn, right? Now the variance of this discrete random variable is denoted by VAR of x, and it is defined as sigma of pi multiplied xi minus x bar whole square, right? Where I takes the values from 1 to n, and this x bar is the mean of this random variable x, or in other words this is also known as the expectation value of x, and x bar is defined as sigma of pi xi, right? And where I takes the values from 1 to n, right? So this is the definition of the variance of this random variable x. So here pi is the probability corresponding to 1, 2, 3 up to n, and xi is the value corresponding to the random variable x, and x bar is the mean of this random variable x, right? So this is the formula for finding out the variance of x. Now we can simplify this formula by expanding this binomial, which is xi minus x bar whole square, right? So what we can write here, so the variance of x can be written as, now if we omit this I equal to 1 to n, and if we simply write sigma, then we have pi, and this binomial xi minus x bar whole square can be written as xi square plus x bar square and minus 2xi x bar, right? Okay, so here the sigma sign implies sigma I equal to 1 to n, right? So for convenience we are writing simply the sign sigma. Now this can further be written as pi xi square multiplying these three terms by pi. We have pi x bar square minus 2 pi xi and x bar, right? Now this can further be written as sigma pi xi square plus sigma pi x bar square, and then we have 2 times sigma pi xi x bar, right? Now see, here we have a sigma of pi xi square, and here if we take x bar square out of this sigma sign, we have sigma of pi, and then we have 2 times x bar, taking x bar because this is independent of I. So taking x bar out of this sigma sign, so we have 2 x bar sigma pi xi, right? Okay, now we can make use of this result, and we also know that sigma of pi is equal to 1, because the sum of all probabilities should be equal to 1. So variance of x can be written as sigma pi xi square plus x bar square, right? Because sigma of pi is equal to 1, right? Minus 2 x bar, and for this term we can write x bar. So here we have x bar. So this can be written as sigma pi xi square, and this is x bar square minus 2x bar square, and this is sigma pi xi square minus x bar square. So the formula for variance of x can also be written like this, right? So either we can write this formula or this formula, right? Now here this formula can also be expressed like this, that is variance of x is equal to sigma pi xi square can be written as the expectation value of x square, right? And x bar is e of x, so this can be written as e of x, and this is square, right? So this is another way of expressing the formula for variance of x, right? So variance of x is sigma of pi xi square minus x bar square, and here we can also write I equal to 1 to n, right? So here's this is the formula for finding out variance of x, and we can solve some problems. Now here we should mention one more thing, that if the variance is given by this formula, then the standard deviation is equal to the square root of variance of x, right? So the standard deviation, which is denoted by sigma, so sigma can be written as sigma this square root of sigma I from 1 to n, then we have pi xi square minus x bar square. So this is the formula for finding out the variance of the probability distribution, right? So once we have the value of variance of x, we can find out the standard deviation of the random variable x. Now let us take this problem. So here a random variable x has the probability distribution. So here the random variable takes the values -2, -1, 0, 1, 2, 3, and the corresponding probabilities are 0.1, k, 0.2, 2k, 0.3, and k. And here we have to find the value of k, the mean of x, the variance of x, and the standard deviation. Now to find the value of this k will make use of the concept that the sum of all the probabilities should be equal to 1, right? So here sigma pi is equal to 1, where I varies from 1 to 6, right? Because here we have this is x1, this is x2, this is x3, this is x4, this is x5, and this is x6, right? And this value is p1, this is p2, this is p3, this is p4, this is p5, and this is p6. So the sum of all probabilities, that is p1 plus p2 up to p6, is equal to 1, right? Okay, so we have 0.1 plus k plus 0.2 plus 2k plus 0.3 plus k is equal to 1, right? Now if we add 0.1, 0.2 and 0.3, we get 0.6, and 2k plus k, 3k plus k, that is 4k, is equal to 1. So 4k is 1 minus 0.6, that is 0.4, and k is 0.4 divided by 4, that is 0.1, that is equal to 1 by 10. So the value of k is 1 by 10, or 0.1. Now our second aim is to find the mean of x. Now the mean of x, which is also known as the expectation value of x, is given by sigma of pi xi, and I varies from 1 to 6, and this is p1 x1 up to p2 x2 up to p6 x6, right? And now we can write p1 x1. So p1 x1 is 0.1 multiplied by minus 2. Then we have k times minus 1, 0.2 times 0. Then we have 2k multiplied 1 plus 0.3 multiplied 2, and then we have k times 3, right? So p1 x1, p2 x2, and so on. So here we have minus 0.2, this is minus k, this becomes 0, this is 2k, this is 0.6, and this is 3k. So we have 2k plus 3k, 5k, minus k, 4k, and 0.6 minus 0.2 is 0.4, right? And the value of k is 0.1, so we have 4 times 0.1 plus 0.4, that is 0.4 plus 0.4, that is 0.8, right? So therefore the mean of this random variable is 0.8, right? Okay, now we have to find the variance of x. So in our discussion, which we have concluded just now, the variance of x is defined as sigma pi xi square minus x bar square, right? So here we have to find the sum of all these products. So here I varies from 1 to 6. It means we have to find p1 x1 square plus p2 x2 square up to p6 x6 square, and then we have here the mean of the square of the mean, right? Okay, so now in order to get this term, what is p1? P1 is 0.1, and x1 is minus 2, and minus 2 square is 4, right? Similarly, we have k times minus 1 square, because x2 is minus 1, so minus 1 square is 1. Then we have 0.2 multiplied 0 square is 0. Then we have 2k times 1 square, because x4 is 1, so this is 1 square, that is 1. Then we have 0.3 times 2 square, that is 4. And then we have k times 3 square, that is 9. And here we have minus x bar square. X bar square is 0.8 square, right? Now this is 0.4, this is k ones are k, this term becomes 0, this is 2k, and this is 1.2, because 0.3 multiplied 4 is 1.2. Then we have 9k, and here we have 0.64, right? 0.8 square is 0.64. Now 1.2 and 0.4 is 1.6, and this is 9 plus 2 11 plus 1, that is 12k minus 0.64, right? Now 12k 1.6 and 0.64 is 0.96, so here we have plus 0.96, right? And the value of k is 0.1, so here if we substitute it, we get 12 times 0.1 plus 0.96, this is 1.2 plus 0.96, and if we add, we get 6, 1, and here we have 2, right? So the value of the variance of x is 2.16, right? Now our next step is to find the standard deviation, and we know that the standard deviation is the square root of variance of x, right? And the variance of x is 2.16 here, so the square root of 2.16 is equal to 1.469, right? So the standard deviation is 1.469, right? Now let us take an important problem. Here we have to find the mean and variance of the number of tails, right? The number of tails in 3 tosses of a coin, right? So here we are tossing a coin thrice, or 3 tosses of a coin, right? Okay, so the sample space for this experiment is we can write h h h h t t t, and then we have h h t t h h t t, right? And then we have ht, ht, then we have ht and ht, right? So the sample space, it contains the events HHH, similarly HHT, HTH, then we have HTT, then we have THH and THT, then we have TTH and TTT, right? So there are 8 outcomes, right? Okay, now here the random variable x, the random variable x is or it takes the values 0, 1, 2 or 3, right? Because the random variable denotes the number of tails, right? So when we take x of h, then this event does not have any tail, so x takes the value 0, right? Similarly, in this case, HHT, the random variable takes the value 1 because here the number of tails is 1, right? And similarly, we can explain the other events, right? So x takes values 0, 1, 2 and 3. In events like this, TTH, x takes the value 2, and in the event TTT, we have the random variable x takes the value 3, right? Okay, so the probability distribution can be written as x, and here we have p of x, and here x takes the value 0, 1, 2 and 3, right? Okay, now here x equal to 0, it means we have to find the probability for no head, right? For getting it is no tail, right? So p of x equal to 0 implies the probability of getting no tail, right? So no tail occurs in this event, right? So the probability is 1 by 8, right? Okay, so this is 1 by 8. Similarly, for x equal to 1, it means the probability of getting one tail, right? So one tail can be obtained in this event, then in this event, and then in this event, right? So the probability is 3 by 8 because the favorable outcomes are 3, 1, 2 and 3. Clear? Okay, now for p of x equal to 2, it means getting two tails. So two tails can be obtained here and here and here, right? So in 3 ways we can get two tails, so the corresponding probability is again 3 by 8. So here we can write 3 by 8, here also we can write 3 by 8. Clear? And p of x equal to 3 implies that getting all the tails, right? So here the event which is favorable to x equal to 3 is this one, and the corresponding probability is 1 by 8, right? Okay, so here we have 3 tails means 1 by 8. So for x equal to 0, we have 1 by 8. For x equal to 1, we have 1, 2 and 3. And for x equal to 2, we have 1, 2 and 3, right? So 3 by 8. And here for x equal to 3, we have only one event, so it is 1 by 8, right? And here we can easily see that the sum of all the probabilities, that is 1 by 8, 3 by 8 plus 3 by 8 plus 1 by 8 is equal to 1, right? Okay, so this is the probability distribution, right? So this is the probability distribution for x, and we have to find the mean and variance, right? So if we write it like this, here in this column we can write x, here we can write px, and here this 0, 1, 2, 3, and here we can write 1 by 8, this is 3 by 8, this is also 3 by 8, and here we have 1 by 8, and here we can write p square, right? Okay, sorry, it is x square. So here we can write x square. So 0 square is 0. Then here we have 1 square is 1. And here we have 2 square, that is 4. And here we have 3 square, 9. And in the next column we can write px times x square. And px times x square is 1 by 8 times 0, that is 0. 3 by 8 times 1 is 3 by 8. And 3 by 8 times 4 is 12 by 8. And 1 by 8 times 9 is 9 by 8. Right? Okay. In the next column, we can also find px times x. Right? Px times x. So 0 times 1 by 8 is 0. 1 times 3 by 8 is 3 by 8. 2 times 3 by 8 is 6 by 8. And 3 times 1 by 8 is 3 by 8. Right? Okay. So we have obtained a table like this, and this is the random variable x, and here we have these columns, right? Okay, now the mean of this random variable x is denoted by x bar, and it is given by sigma of pi xi, right? So sigma of pi xi, it means sigma of px times x, and sigma of px times x means the sum of all these quantities, that is 0 plus 3 by 8 plus 6 by 8 plus 3 by 8, right? So this is 6 plus 3 9 plus 3 12, and it is 12 by 8, that is 4 3s are, and this is 4 2s are. So this is 3 by 2, that is 1.5. So the mean of this distribution is 1.5. Okay, now we have to find the variance. Now the variance can be obtained by the formula, that is variance of x is sigma pi xi square minus x bar square. Now sigma of pi xi square is same as sigma of px times x square, and this is x bar square. So we have to add all these numbers. So this is 0 plus 3 by 8 plus 12 by 8 plus 9 by 8, and here for x bar square we have 3 by 2 square, right? Now this is, if we add all these three numbers, so this is 15 plus 9 24 by 8, and this is 9 by 4, right? 3 square 9, 2 square 4, and this is 8 3s are, and this is 3 minus 9 by 4, and this is 4 3s are 12 minus 9 by 4, that is equal to 3 by 4. And the variance of this random variable is given by 3 by 4, and 3 by 4 can be written as 0.75, right? So this is 0.75. Clear? Okay. Now if we wish to find the standard deviation, then the standard deviation is the square root of variance of x, and this can be written as square root of 0.75, and if we calculate the square root of 0.75, we get approximately 0.866, right? So this is the standard deviation, right?